In the lexicon of modern military history, few machines serve as a more distinct marker of strategic pivots than the Oshkosh M-ATV, the mine-resistant, ambush-protected all-terrain vehicle. Its existence is not merely the result of a procurement cycle, but a direct physical response to a shift in the gravity of the global war on terror. By late 2008, the operational focus of the United States military and its NATO allies began to swing violently from the urban sprawls and flat highways of Iraq to the jagged, vertiginous hinterlands of Afghanistan. The conflict in Iraq had birthed the first generation of MRAPs, behemoths like the International Max Pro and the Force Protection Cougar. These vehicles were engineering marvels of blast deflection, designed to survive the massive underbody detonations of improvised explosive devices buried beneath paved roads. However, they were engineered for survivability, not agility. Top-heavy, rigid, and massively overweight, they were essentially bank vaults on wheels. When these vehicles were deployed to the Hindu Kush, the terrain proved as lethal as the enemy. The primitive dirt tracks, narrow switchbacks, and steep gradients of Afghanistan exposed the severe mobility limitations of the legacy MRAP fleet. Rollovers became endemic, and the physical inability of a 40,000-pound Max Pro to ascend a 60% scree slope left commanders with a grim choice: stay on the predictable, mined roads in a heavy MRAP, or go off-road in a vulnerable Humvee and risk catastrophic loss of life from underbody blasts. The Department of Defense identified this critical capability gap and issued an urgent operational requirement for a vehicle that could thread the needle. The mandate was paradoxical. The vehicle required the ballistic survivability of a heavy MRAP, but the off-road agility and profile of a light tactical truck. It had to traverse 60% grades, navigate 30% side slopes, and survive blasts that would vaporize a light utility vehicle, and it had to be fielded immediately. Oshkosh Defense secured the contract in June 2009, responding with a design that leveraged existing combat-proven subsystems to compress the development timeline. By mating a modified medium tactical vehicle replacement chassis with a Plasan-designed armored capsule, Oshkosh produced the M-ATV. The M-ATV program was one of the fastest major procurement efforts in U.S. military history. Brigadier General Michael Brogan, the Marine Corps program officer, noted that the Oshkosh bid was selected not only for its technical superiority, but also for its manufacturing viability. Oshkosh possessed the industrial capacity to scale production rapidly, a critical factor given the deteriorating security situation in Afghanistan. The initial delivery order, valued at over $1 billion, called for 2,244 vehicles. This requirement ballooned almost immediately. By June 2009, the requirement had increased to 5,244 units, split across the Army, Marines, Special Operations Command, Air Force, and Navy. The speed of this ramp-up, from contract award in June to boots-on-the-ground capability in Kandahar by October 2009, underscores the urgency of the program. The financial scale of the M-ATV program reflects its priority. The unit cost for an M-ATV hovers around $470,000 for the base vehicle, but when fully equipped with mission equipment packages and logistics support, the cost rises significantly. Government Accountability Office data indicates an average unit cost of approximately $1.4 million when factoring in transportation and mission equipment. This immense investment, totaling over $12.5 billion through fiscal year 2024, was justified by the casualty reduction statistics provided by the V-hull design. The M-ATV represents a divergence from the unibody construction of vehicles like the Cougar. Instead, it utilizes a body-on-frame architecture. This decision was driven by the necessity of using the existing medium tactical vehicle replacement chassis to meet the timeline. The crew compartment, or citadel, is a distinct armored pod bolted to the chassis frame. Developed in partnership with Plasan North America, a subsidiary of the Israeli armor firm Plasan Sasa, the capsule features a complex composite armor solution. The defining feature of the M-ATV's survivability is the V-shaped hull. In a flat-bottomed vehicle like a Humvee, the blast wave from a buried mine strikes the floor perpendicular to the surface. This transfers nearly 100% of the kinetic energy and impulse directly into the vehicle structure, causing catastrophic hull breach and imparting lethal vertical acceleration to the occupants. The M-ATV's V-hull works on the principle of deflection. The angle geometry splits the blast wave, redirecting the high-pressure gas and debris laterally away from the capsule. Research indicates that lower internal angles on the V-hull offer greater deflection capabilities, significantly reducing the impulse transferred to the cabin. The armor is not merely steel. Plasan utilizes a combination of high-hardness steel, providing the structural backbone and protection against small arms fire, ceramic composites used in smart armor solutions to break up the penetrators of armor-piercing rounds, and spall liners, perhaps the most critical component for crew survival during a kinetic strike. When a projectile like an RPG or explosively formed penetrator impacts the outer armor, the shockwave can cause the interior face of the armor to shatter, spraying the cabin with high-velocity razor-sharp fragments known as spall. Plasan spall liners made of aramid or fiberglass composites act as a catch layer, absorbing this debris and significantly reducing the spall cone angle to protect the crew. The M-ATV was designed to be adaptable. The base protection level can be augmented with the underbody improvement kit, which adds additional plating to the belly to counter larger IEDs. Furthermore, explosively formed penetrator kits can be bolted to the sides. However, this protection comes at a cost: weight. The curb weight is approximately 25,000 to 27,500 pounds, depending on the variant. The gross vehicle weight can reach up to 32,500 pounds, fully loaded. This immense mass is the central antagonist in the M-ATV's mechanical life. The engine, suspension, and drivetrain are locked in a perpetual struggle against the gravity of the armor package. Before we continue, have you ever seen one of these beasts in real life? Drop a comment below and share your experience. And if you're enjoying this deep dive into military engineering, hit that like button and subscribe so you don't miss our upcoming videos on other incredible machines of modern warfare. Oshkosh markets their integrated survivability suite as Core 1080. This includes not just the hull, but the energy-attenuating seats. Unlike standard automotive seats bolted to the floor, M-ATV seats are often suspended from the ceiling or mounted on energy-absorbing stroking mechanisms. In the event of a blast that accelerates the vehicle upward, the seats decouple the occupant from the G-forces, preventing spinal compression injuries that were common in earlier conflicts. The heart of the M-ATV is the Caterpillar C7 ACERT engine. It is a 7.2-liter inline-six turbocharged diesel power plant. In this military application, it is tuned to produce 370 horsepower and 925 pound-feet of torque. While 925 pound-feet suggests immense capability, the specific power-to-weight ratio of approximately 25 horsepower per ton means the engine is working near its limit to move the 14-ton vehicle through mountainous terrain. The C7 utilizes a hydraulically actuated, electronically controlled unit injector fuel system, a technology that differentiates it from common rail diesels. In this system, fuel pressure is not generated by a fuel pump alone. Instead, a high-pressure oil pump pressurizes engine oil up to 3,000 plus pounds per square inch, which is then supplied to the injectors. When the engine control module signals injection, this high-pressure oil acts as a hydraulic ram to pressurize the fuel inside the injector. This system makes the engine's reliability inextricably linked to the cleanliness of its oil. The high-pressure pump shears the oil molecules, degrading viscosity faster than in standard engines. In the fine dust environments of Iraq and Afghanistan, keeping oil pristine is nearly impossible. If dirt enters the oil via a loose dipstick or dirty fill bucket, it flows into the high-pressure oil pump. The pump wears rapidly, sending metal shavings downstream. These shavings enter the oil passages of the injectors, instantly destroying all 6 fuel injectors. This cascading failure is a well-documented issue with C7 engines in fleet service. Soldiers and mechanics refer to this as a mission kill that requires a complex, clean room level repair, often unavailable at the forward operating base level. The MATV operates in environments exceeding 120 degrees Fahrenheit, often idling for hours to power communications and surveillance equipment. The armored hood restricts airflow, creating a thermal nightmare. The C7 engine control module is programmed with self-preservation logic derived from commercial trucking. If coolant temperatures spike, often above 230 degrees Fahrenheit, or oil pressure drops, the module triggers limp mode. This derates the engine power, limiting the vehicle to crawling speeds of around 5 miles per hour to save the block. While mechanically prudent, this feature is tactically dangerous. Soldiers have reported instances of vehicles entering limp mode during combat operations or while negotiating dangerous terrain, effectively stranding the crew. Field improvisations often involve cycling the master power switch to reset the engine control module temporarily, a reboot tactic that risks further damage but restores mobility for a few crucial minutes. Conversely, in the freezing winters of the Afghan mountains, the C7 can be reluctant to start. The intake heater grid is the primary starting aid. However, in extreme cold, with claimed capabilities down to -26 degrees Fahrenheit, the engine struggles. Despite strict prohibitions in operator manuals against using starting fluid, also known as ether, due to the risk of shattering piston rings or exploding the intake heater, anecdotes suggest it is a common field expedient method. An engine addicted to ether, one that won't start without it due to damaged rings, is colloquially known as an ether baby. Transferring the C7's torque to the wheels is a robust, if complex, drivetrain system designed for extreme grades. The transmission is an Allison 3500 SP Specialty Series, a 6-speed automatic unit designed for military and heavy-duty applications. It features a torque converter with a lockup clutch. This allows for fluid coupling during low-speed maneuvering, preventing stalls, and direct mechanical connection at highway speeds, improving efficiency. The transmission communicates with the engine to momentarily reduce torque during gear changes. This protects the clutch packs and shafts from the shock of shifting a 30,000-pound vehicle under load. Power is routed through a Marmon-Harrington transfer case offering high and low ranges. The low range is critical for achieving the 60% grade climbing requirement, multiplying the torque to crawl up steep inclines. The axles, derived from the medium tactical vehicle replacement, feature driver-actuated locking differentials. When engaged, these lock the left and right wheels together, forcing them to turn at the same speed. This is essential for mud, sand, or snow. A common failure mode involves operators leaving the differentials locked on hard surfaces. This causes driveline windup during turns, where the difference in wheel travel distance builds immense stress in the axles until a shaft snaps with a loud report. If the V-hull is the shield, the TAK4 suspension is the legs. This system is widely regarded as the M-ATV's defining engineering achievement, distinguishing it from the solid axle designs of the Max Pro. The TAK4 is a double wishbone independent suspension system. Unlike a solid axle, where an impact on one wheel affects the entire axle assembly, the TAK4 allows each wheel station to articulate independently. The system boasts an impressive 16 inches of independent wheel travel. This allows the vehicle to absorb massive ruts and rocks without transmitting the full shock to the chassis. The M-ATV utilizes heavy-duty coil springs. The upper and lower control arms are massive castings designed to withstand the lateral forces of a 14-ton vehicle drifting on gravel. The primary tactical advantage of the TAK-4 system is speed. Oshkosh claims a 70% off-road duty cycle, meaning the vehicle is engineered to spend the majority of its life off-road. On the washboard roads of Afghanistan, a solid axle MRAP is limited to 10 to 15 miles per hour before the vibration becomes physically debilitating for the crew and destructive to the vehicle electronics. The MATV, with its 16 inches of travel, can traverse the same terrain at 30 to 45 miles per hour. This mobility is a defensive attribute. A faster-moving convoy reduces the enemy's engagement window and complicates the timing of IED detonation. The complexity of the TAK-4 system introduces maintenance liabilities. The entire weight of the vehicle corner rests on the ball joints connecting the control arms to the steering knuckle. These joints require rigorous lubrication schedules. In combat, where maintenance intervals are often stretched, the grease can dry out or become contaminated with sand. There have been documented issues in similar TAK-4-equipped vehicles where neglected ball joints fail, leading to the steering knuckle separating and the wheel assembly collapsing under the vehicle. This is a catastrophic failure mode at speed. The interface with the terrain is managed by massive Michelin XZL tires equipped with run-flat inserts. The M-ATV features a central tire inflation system that allows the driver to adjust tire pressure from the cab. The system has 4 settings: highway, cross-country, mud, sand, snow, and emergency. By lowering pressure in sand mode, the tire footprint elongates, increasing flotation on soft surfaces. This is critical for avoiding bog downs in dry riverbeds. The central tire inflation system is notoriously fragile. The air is routed through the center of the wheel hub via rotating seals. These seals are prone to failure. A common symptom is a constant hissing sound from the wheels when parked. If the system detects a leak or cannot maintain pressure, it triggers a fault. In some software versions, a major air system fault can interact with the transmission or engine controls, restricting vehicle performance. Operators frequently disconnect or bypass the central tire inflation system in the field to prevent the compressor from burning out, resorting to manual pressure checks. Inside the armored capsule, the reality of operating the M-ATV is a mix of high-tech protection and ergonomic brutality. Entering the M-ATV requires climbing nearly 4 feet up the side of the hull. The doors are incredibly heavy, armored slabs assisted by hydraulic cylinders. The doors feature a mechanical deadbolt system known as the combat lock to prevent forced entry. These locks are a frequent point of failure. Dust ingress can cause the internal linkage to jam, trapping the crew inside or preventing the door from latching. The prevalence of jammed doors led to the issuance of the Universal Combat Lock Tool, a specialized manual tool designed to mechanically override the lock from the exterior. Essentially, the vehicle comes with a tool to break into itself because the locks are so unreliable. The interior door handles are widely regarded as under-engineered for the weight of the door. Soldiers frequently snap them off, leading to improvised repairs using paracord or locking pliers to operate the latch. The V-hull design necessitates a high floor, and armor requirements dictate small windows. The blind spot analysis is sobering. An average height person standing within 1 meter of the front bumper is completely invisible to the driver. This dead zone makes maneuvering in populated villages extremely hazardous, requiring constant communication with the vehicle commander or ground guides. Rear visibility is virtually non-existent due to the small rear window and the obstruction of the communications and surveillance equipment rack. Drivers are entirely dependent on side mirrors and the rear view camera, both of which are easily obscured by mud. The C7 engine is mounted partially intruding into the cabin firewall. Combined with the transmission whining beneath the floor and the aggressive tread of the tires, the interior noise level is punishing. Soldiers describe a screaming whine that persists for hours, necessitating the use of noise-canceling headsets for intercom communication. The MATV is a rolling node in the network-centric battlefield. It carries a suite of command, control, communications, computers, intelligence, surveillance, and reconnaissance gear. A massive metal rack houses radios, jammers, and the Blue Force tracker computer. This rack is typically mounted in the center of the cabin, dominating the interior space. The rack limits the ability of the crew to move between front and rear seats. In a rollover, loose equipment from this rack can become secondary missiles inside the cabin. The M-ATV platform is modular, spawning several variants tailored to specific mission profiles. The Special Operations variant is optimized for the unique requirements of Special Forces teams. It is configured for 5 occupants, driver, vehicle commander, 2 rear passengers, and a dedicated gunner in the turret. A key differentiator is the cargo area. The Special Operations variant features a modified rear section that allows access to the cargo bed from the main cabin. This enables the gunner or crew to reload weapons or access specialized gear without exiting the vehicle's armor protection. It often features a larger single-pane windshield to improve the driver's field of view for high-speed technical driving. The utility variant replaces the rear passenger area with an extended flatbed equipped with standardized cargo locks. It serves as a protected prime mover for generators, pallets of water, or ammunition, bringing logistics support to areas where unarmored trucks cannot survive. A dedicated medical evacuation variant is capable of carrying stretchers in a protected environment. This addresses a critical gap, as standard field ambulances were too vulnerable for the Afghan theater. The assault variant features an extended wheelbase to increase interior volume. It allows for modular seating arrangements, potentially carrying up to 11 personnel, though practical combat loads usually limit this. It features additional roof hatches for vertical deployment. The M-ATV is a maintenance-heavy beast. The complexity that gives it mobility also gives it a high mean time between failure for minor components. Soldier accounts from maintenance forums paint a picture of a vehicle that is difficult to work on. The engine is buried under the armored hood and the cab. Accessing the rear of the engine or the top of the transmission often requires removing armor panels or accessing through the doghouse inside the cab. During the surge, the supply chain struggled to keep up with the demand for ball joints, control arms, and fuel injection pumps. This led to cannibalization, where parts were stripped from damaged vehicles to keep others running. The automatic fire extinguishing system uses optical and thermal sensors to detect explosions or fires. It is designed to suppress fuel fires instantly. However, the system is sensitive. A severe jolt from landing a jump or hitting a deep rut can sometimes trick the sensors, triggering an accidental discharge. The sudden bang of the squibs and the cabin filling with white chemical agent can cause panic, with crews momentarily believing they have been hit by an IED. The M-ATV was the bridge between the Humvee and the Joint Light Tactical Vehicle. It proved that independent suspension and V-hulls were compatible. The Joint Light Tactical Vehicle, also built by Oshkosh, effectively took the M-ATV concept and shrank it by 30%, utilizing the next-generation TAK-4 intelligent suspension with adjustable gas springs to further improve ride quality and transportability. As the U.S. draws down its MRAP fleets, the M-ATV has found a second life through foreign military sales. Nations like Uruguay have begun receiving refurbished M-ATVs to modernize their peacekeeping and defense forces. Saudi Arabia and other Middle Eastern allies also operate the platform, keeping the M-ATV relevant in conflicts like the Yemeni Civil War. The Oshkosh M-ATV stands as a testament to engineering under pressure. Born from a desperate need to save lives in the mountains of Afghanistan, it succeeded where its predecessors failed. It successfully married the ballistic protection of a tank with the suspension dynamics of a desert racer. The vehicle is not without its flaws. The C7 engine's fuel injection system is a ticking time bomb in dusty environments. The door locks are a constant source of frustration, and the visibility limitations require heightened situational awareness. Yet for the thousands of soldiers who hit an IED in an M-ATV and walked away, shaken but alive, these mechanical quirks are forgiven. The M-ATV ran toward danger, carrying its crew over terrain that no other armored vehicle could conquer, earning its place in history as the Iron Camel of the Forever War.